Testing computer application controls have two general approaches. The first one is the black box or around the computer approach, and the second one is the white box or through the computer approach. Black box approach. Auditors testing with the black box approach do not rely on a detailed knowledge of the application's internal logic. Instead, they seek to understand the functional characteristics of the application by analyzing flowcharts and interviewing knowledgeable personnel in the client's organization. The advantage of the black box approach is that you don't have to remove application from operations to test it. This approach is feasible for testing applications that are relatively simple. The second approach is the white box approach. The white box approach relies on an in-depth understanding of the internal logic of the application being tested. These techniques use small numbers of specially created test transactions to verify specific aspects of an application's logic and controls. In this way, it allows auditors to conduct precise tests with known outcomes, which can be compared objectively to actual results. Some of the more common types of tests of controls include the following. First, authenticity tests, which verify that an individual, a program procedure, or a message such as an EDI transmission attempting to access a system is authentic. Authenticity controls include user IDs, passwords, valid vendor codes, and authority tables. The second one is the accuracy tests, which ensure that the system processes only data values that conform to specified tolerances. So the examples of the accuracy tests include range tests, field tests, and limit tests. Another test method is completeness tests, which identify missing data within a single record and the entire records missing from a batch. So the types of tests performed are field tests, record sequence tests, hash totals, and control totals. The fourth method is the redundancy tests, which determine that an application processes each record only once. So the redundancy controls include the reconciliation of batch totals, record counts, hash totals, and the financial control totals. Fifth is the access test, which ensure that the application prevents authorized users from unauthorized access to data. So access controls include passwords, authority tables, user-defined procedures, data encryption, and inference controls. Another test method is the audit trail tests, which ensure that the application creates an adequate audit trail. This includes evidence that the application records all transactions in a transaction log, posts data values to the appropriate accounts, produces complete transaction listings, and generates error files and reports for all exceptions. So the last test method is the rounding error tests, which verify the correctness of rounding procedures. Rounding errors occur in accounting information when the level of precision used in the calculation is greater than that used in the reporting. For example, interest calculations and bank account balances may have a precision of 5 decimal places, whereas only 2 decimal places are needed to report balances. So if the remaining 3 decimal places are simply dropped, the total interest calculated for the total number of accounts may not equal the sum of the individual calculations. So this technique uses an accumulator to keep track of the rounding differences between calculated and reported balances. So failure to properly account for this rounding difference can result in an imbalance between the total interest amount and the sum of the individual interest calculations for each account. And the poor accounting for rounding differences can also present an opportunity for fraud. Rounding programs are particularly susceptible to salami frauds. Salami frauds tend to affect a large number of victims, but the harm to each is immaterial. This type of fraud takes its name from the analogy of slicing a large salami, the fraud objective, into many thin pieces. Each victim assumes one of these small pieces and is unaware of being defrauded. So the next topic that I'm going to present is the computer-aided audit tools and techniques for testing controls. This section describes 5 computer-aided audit tools and techniques approaches. The test data method, which includes base case system evaluation and tracing, integrated test facility, and the parallel simulation. First is the test data method. The test data method is used to establish application integrity by processing specially prepared sets of input data through production applications that are under review. The test data uses a test deck. When creating test data, auditors must prepare a complete set of both valid and invalid transactions. If test data are incomplete, auditors might fail to examine critical branches of application logic and error-checking routines. Test transactions should test every possible input error, logical process, and irregularity. The results of each test are compared to predetermined expectations to obtain an objective evaluation of application logic and control effectiveness. In addition, the auditor must review the updated master files to determine that account balances have been correctly updated. The test results are then compared with the auditor's expected results to determine if the application is functioning properly. This comparison may be performed manually or through special computer software. The second technique is the base case system evaluation. The base case system evaluation is one of the variants of test data method. When the set of test data in use is comprehensive, the technique is called the base case system evaluation. The base case system evaluation tests are conducted with a set of test transactions containing all possible transaction types. These are processed through repeated iterations during systems development testing until consistent and valid results are obtained. These results are the base case. When subsequent changes to the application occur during maintenance, their effects are evaluated by comparing current results with base case results. Another type of the test data technique is called tracing. A tracing is a test data technique that takes step-by-step walkthrough application. The tracing procedure involves 3 steps. First, the trace option must be enabled for the application. Second, specific data or types of transactions are created as test data. Third, test data is traced through all processing steps of the application, and a listing is produced of all lines of code as executed. The test data techniques have advantages and disadvantages. There are 3 primary advantages of test data techniques. First, they employ through the computer testing, thus providing the auditor with explicit evidence concerning application functions. Second, if properly planned, test data runs can be employed with only minimal disruption to the organization's operation. Third, they require only minimal computer expertise on the part of the auditors. The disadvantages of the test data techniques are first, auditors must rely on information system personnel to obtain a copy of the application for testing. This entails a risk that computer services may intentionally or accidentally provide the auditor with the wrong version of the application and may reduce the reliability of the audit evidence. The second disadvantage of these techniques is that they provide a static picture of application integrity at a single point in time. They do not provide a convenient means of gathering evidence about ongoing application functionality. A third disadvantage of these techniques is their relatively high cost of implementation, which result in an audit inefficiency. The auditor may devote considerable time to understanding program logic and creating test data. Another approach is the integrated test facility. This approach is an automated technique that enables the auditor to test an application's logic and controls during its normal operation. The ITF is one or more audit modules designed into the application during the development process. ITF databases contain dummy or test master file records integrated with the legitimate records. In ITF, audit modules are designed to discriminate between ITF transactions and routine production data. This may be accomplished in a number of ways. One of the simplest and most commonly used is to assign a unique range of key values exclusively to IT transactions. By segregating ITF transactions from legitimate transactions, routine reports produced by the application are not corrupted by ITF test data. Test results are produced separately on storage, media, or hard copy output and distributed directly to the auditor. The auditor analyzes ITF results against expected results. ITF has advantages and disadvantages. The ITF technique has two advantages over test data techniques. First, ITF supports ongoing monitoring controls as required by SAS 78. Second, applications with ITF can be economically tested without disrupting the user's operations and without the intervention of computer service personnel. Thus, ITF improves the efficiency of the audit and increases the reliability of the audit evidence gathered. The primary disadvantage of ITF is the potential for corrupting the data files of the organization with test data. Steps must be taken to ensure that ITF test transactions do not materially affect financial statements by being improperly aggregated with legitimate transactions. The remedy in this problem are adjusting entries may be processed to remove the effects of ITF from general ledger account balances, or the data files can be scanned by special software that remove the ITF transactions. The last approach is the parallel simulation. Parallel simulation requires the auditor to write a program that simulates key features or processes of the application under review. The simulated application is then used to process the transactions that were previously processed by the production application. The steps in performing parallel simulation testing are: first, auditor gains a thorough understanding of the application under review. Second, auditor must identify those processes and controls critical to the application. Third, auditor creates the simulation using program or generalized audit software. Fourth, auditor runs the simulated program using selected data and files. Fifth, or last, auditor evaluates results and reconciles differences.